x squared minus 6x plus 10 raised to the power of x squared minus 8x plus 16 equals to 1. We have to solve for x. Now, when x squared minus 6x plus 10 raised to the power of x squared minus 8x plus 16 equals to 1, there are three scenarios for this. Case 1 is when base is 1 and the exponent is x, then it doesn't matter, it will be equal to 1. Case 2 is when the base is x and the exponent is 0, so base doesn't matter. And case 3 is when the base is negative 1 and the exponent is negative or positive even number, then also it is equal to 1. Now let's take the case 1 where the base is 1. So in that case, x square minus 6x plus 10 equals to 1 because the exponent doesn't matter here. Now let's factorize it. X square minus 6x, 1 to the left hand side, so plus 9 equals to 0, or x square, we have to find two numbers whose product is 9x square and whose sum or difference is 6x. So we can write minus 3x plus 9. Minus 3x times minus 3x will be positive 9x square, and minus 3x equals to minus 6x, or x common here, so x minus 3, again minus 3 common here, so x minus 3 equals to 0. So this is x minus 3 common, and then x minus 3, remaining factor equals to 0. So x minus 3 square equals to 0, or x minus 3 equals to 0. Therefore x equals to 3. So in the first case, x equals to 3. Now case 2, when the base doesn't matter, it is x raised to the power of 0. That means the exponent is equal to 0. Exponent here is x square minus 8x plus 16. So x square minus 8x plus 16 equals to 0, or x square minus 8x, we can write minus 4x plus 16 equals to 0, or x minus 4, then minus 4 x minus 4 equals to 0. So this is equal to x minus 4 square, or x equals to 4. So in that case, we have x equals to 4. Now in case third, when we have minus 1 and raised to the power of even number, negative or positive, so here in that case we have x square minus 6x plus 10 equals to minus 1, or x square minus 6x plus 11 equals to 0. We cannot factorize it. We can find the roots using the discriminant formula, as this is a quadratic equation where a here is the coefficient of x square, that is 1, b here is minus 6, coefficient of x, and c here is 11. So x equals to minus b plus minus b square minus 4ac under square root upon 2a. So minus 6 plus minus 6 square minus 4 times 11 upon 2. So 6 plus minus 36 minus 44 upon 2 equals to 6 plus minus 8 under square root upon 2, or we can write it as 6 plus minus 8 under square root times minus 1 under square root upon 2. Minus 1 is an imaginary number, we write iota for it. So 6 plus minus 2 times square root of 2 I upon 2. Let's take 2 common here. So 3 plus minus square root of 2i upon 2. So 2 and 2 gets cancelled. So other complex solution can be 3 plus minus square root of 2i. Now let's verify. First solution for x is x equals to 3. So 3 square minus 6 times 3 plus 10 raised to the power 3 square minus 3 times 8 plus 16. This should be equal to 1. 9 minus 18 plus 10, and here also 9 minus 24 plus 16. So this is 19 minus 18 25 minus 24. So 1 to the power 1 equals to 1. So this checks out. X equals to 3. Now let's plug in when x equals to 4. So when x equals to 4, 4 square minus 6 times 4 plus 10. 4 square minus 8 times 4 plus 16. And this should be equal to 1. So it is 16 plus 10, 26 minus 24 to the power of 32 minus 32. So it is 2 to the power 0 equals to 1. 2 to the power 0 is 1. So 1 equals to 1. So this also checks out. X equals to 4. Now two complex solutions that we got. When x equals to 3 plus square root of 2i. Now the complex solutions for x that we got, there were two values when 3 plus square root of 2i and when x equals to 3 minus square root of 2i. When we plug in this value, this should given, when we plug this value in x square minus 8x plus 16, this should give us an even value because we considered the case as minus n minus 1 to the power of 2 to the power n. So let's first plug in 3 plus square root of 2i. So 3 plus square root of 2i square minus 8 times square root of 2 minus 8 times 3 plus square root of 2i plus 16. So it is 3 square plus 2 times 3 times square root of 2i plus square root of 2i square minus 24 minus 8 times square root of 2i plus 16 equals to 2n. So 9 plus 16, 25 minus 24, 1 plus 6 times square root of 2i plus square root of 2 square times I square minus 8 times square root of 2i equals to 2n. So 1 plus 6 minus 8, so minus 2 times square root of 2i. The square root gets cancelled with this square, so it is 2 and I square is minus 1 equals to 2n. So this is minus 1 minus 2 times square root of 2i equals to 2n. So this does not give us a positive value, it is giving us a negative value. Therefore x is not equal to 3 plus square root of 2i. In the same manner we can find x is also not equal to 3 minus square root of 2i. So these two are not the solution. Only two solutions for x are x equals to 3 and 4. 3 or 4. How did you solve it? Let me know in the comment section. Thanks for watching.